We started doing problems that look like these yesterday, and we saw how to calculate amplitude, period, midline, and all that kind of stuff yesterday with equations that look similar but not quite the same. There's one thing about these that might throw you off just a little bit. We got the extra set of parentheses, right? If that is throwing you off here, I'll tell you right now, you do not actually distribute with these. That's not going to affect anything here, but you don't have to worry about distributing. You want to leave that number factored out. There's some little details going on behind the scenes there, but basically what's going on is that we need to be able to take a look at these sorts of things, and this would actually tell us that it's moved over 90, not 5 times 90. All right, but still, the number that's being multiplied inside is the 5, and so that's going to be the one that's going to actually be affecting our answer. So with that in mind, keep going through using the same techniques that we did yesterday. So to get these answers here, for the period, remember the period is determined by whatever is multiplied by x or theta. In this case, it's the 5. That means it's completing 5 full cycles within the normal 360 degrees. So I do 360 divided by 5, and that gives us a period of 72 degrees. So in other words, if I'm looking at one full cycle of my graph from top back to the top again, it's going from 0 over to 72 in order to complete that whole thing. All right, amplitude. Amplitude, remember, is determined by whatever is multiplied out front of cosine. If I'm not writing anything multiplied out front, then it's just got to be a 1. It's unchanged, telling us that if I take a look at the graph here, that this distance here is 1, because that's what amplitude means, that distance from the midline to the top or the bottom. And then finally, for the midline, remember, yes, it is y equals because it's actually a line, not just a number. But this is determined by our vertical shift, however far we move it up or down. Now, since there's nothing added on the end here, that's why it's a 0, telling us that this midline here is at y equals 0. And for every single one of these, we're going to do it the same way. Notice that as we did those, though, that's plus 90. It didn't change any of those 3. That's just a horizontal shift. All right, the rest of the answer. Go ahead and check each of those. Make sure they're looking good. And again, notice amplitude is always positive, so it's a positive 4 there. All right, so today we are adding an element to the actual graphs that we're making. We are now going to be taking a look at changing that period and then translating that into the graph we make. All right? So we've already seen how to calculate period. In fact, you already have notes that you wrote down yesterday specifically on this particular equation with the 2 in there. We saw that in order to figure out what my period is, I'd be doing 360 divided by 2 to get 180 as my new period. We talked about this example yesterday. There's a little refresher, because it's always 360 divided by whatever that number is on the inside, multiplied. Now, what that means, remember, is that my cosine graph is no longer going to be looking quite like this. Instead of completing this full cycle like this from top to top at 360, I have to do that exact same thing by the time I hit 180. So it's like I got to take this whole graph and squish it over. It's not a shift, it's a squish, it's a compression. So how are we going to do that? Well, when I make this graph, how often am I plotting a point? How many degrees do I go over each time? So if I normally would put that first point at 90, I got to compress this, right? Got to squish it over. So what's it going to be instead of 90? Yeah, it's going to have to now be 45 degrees. And so basically what we're doing is that instead of putting my top, middle, bottom at 90 degree intervals, I'm going to go top, middle, bottom at 45 degree intervals. And so if we look at doing that, of course, this is still cosine. If you want to go ahead and draw in those dotted lines for top, middle, and bottom, yes, that is still a good strategy. I'm not doing that in this case just because I'm already going to have enough extra marks on there and I don't want to confuse all the stuff that's going on. But cosine starts at the top, so I'm going to put my first point at the top. Yes, we're assuming that our vertical scale here is 1. Cosine starts at the top, and then we know the pattern from there, right? It goes top, middle. It's just that now notice where the middle is. The middle is now over here at 45 degrees. And then bottom. I go over 45 degrees more, so that's now at 90. And then I go over another 45 degrees. Middle, another 45 degrees, top. And then I can go ahead and I can draw the curve that goes through those points. You now have at least part of your graph. Now I say part because we haven't filled up our graphing grid, have we? And so we do actually want to extend this out because, of course, this is a periodic function. It repeats itself over and over and over again into infinity. And so obviously, yes, there's going to be graph over here. So follow that pattern, please. Go ahead and extend that graph out to fill up your grid. And so then this would be your actual final graph. Now, let's go back just a little bit to those notes we took yesterday. We talked about this number, technically called the frequency, and what that number does when it comes to period. Remember that that number tells me how many full cycles we will complete in our normal 360 degrees. So basically, between here and here, how many cycles did I complete? I went from top to top here, so that's one full cycle at this point, and then another top to top again. So notice, 2 full cycles completed. And that's what that's telling us, is that between 0 and 360, I got to do 2 full cycles of my wave, or 2 revolutions around the circle if we're relating it back to the circle picture where all this stuff came from originally. Go ahead and now try graphing this one on your own using the same kind of techniques that we talked about. All right, so first thing I want to do in looking at this problem and how we make the graph is I'm actually going to calculate out what the period would be. So the period is going to be 360 divided by that b value. So divided by a half. Remember, in order to divide by a half, that's the same thing as multiplying by 2. So that is going to give me 720 degrees for my new period. In other words, it is twice as wide as it otherwise would have been. Now, if it's going to be twice as wide, if we're going to have to complete one full cycle all the way out here at 720, notice in the graph that I'm given here between 0 and 360, I'm not even going to complete a full cycle here. In fact, I'm only going to complete half of a cycle. So instead of putting a point every 90 degrees, I'm going to be putting a point every 180 degrees. All right, so let's go ahead and now put those in. Help if I'm on the eraser tool. There we go. All right, so first point, still at the top. Notice this didn't change that. Cosine is still going to start at the top of the wave. I then go to the middle, same as always. It's just that the middle is now all the way over here at 180. It's twice as far out as it otherwise would have been. And then we go to the bottom. The bottom is over another 180 degrees. And those are the only points that are going to fit, so now we can go ahead and we can draw in our curve that goes through that, or at least try to. It's a little bit harder on these to sometimes get them to have that curve looking good. Might take a couple tries, but it's worth doing it right. Now, if you have trouble seeing what those intervals are, there's actually a couple different ways that we could know to put a point every 180 degrees. And it actually comes back to this same idea here, where we figured out what our period was. When I make my normal cosine graph, I take my 360 and I cut it up into 4 pieces, right? Notice 360 divided by 4 is 90. Well, if I do 720 degrees divided by 4, it gives me 180 degrees. So if you can't just look at it and know, you could always do that. You could take your entire period and divide it up into 4 pieces, and that will tell you how big each piece is going to be. Alternately, if you feel a little bit better about it, I even could have taken the 90 degrees and divided it by a half. That would give me 180. And so rather than doing 360 divided by a half, which is, by the way, the only way to get period, this does not mean period. This tells you your increment. But if you'd done 90 divided by a half, notice it does give me 180. It tells me that I'm doubling my normal increment amount. Personally, I think of it this way. I take my period, and then I just divide it up into 4 pieces. Continuing our graphing practice, I don't want you to forget about all those other transformations that we have learned about. So please write down this equation above your next graphing grid and graph it. So now going through this particular one, there's now a lot of moving parts. This is where I would definitely say draw in the midline first, and then the lines for the top and the bottom of our wave. So midline first. My midline here is going to be wherever the vertical shift is. So my midline is y equals 1. Draw that in as a dotted line. Yes, dotted every time. If it's solid, we're saying it's a point on the graph. Dotted, we're saying it's a guide. And these are just guides here. Next up, I need to know what the amplitude of my graph is. Remember, amplitude comes from whatever we're multiplying by. It's our vertical stretch. So the amplitude here is 2. Why do I care? Because the amplitude tells me how high above my midline the top is, and how far below the midline the bottom is. So notice, both of these distances here are 2. That is amplitude. Every time, that distance is whatever the amplitude is. All right, one other question here. What's our period in this graph? So to figure out what the period is, we look to see what am I multiplying theta by. Well, I'm not multiplying theta by anything. It's like there's a 1 there. Remember, to figure out period, we end up doing 360 divided by whatever that number is. 360 divided by 1 is still just 360. So my period here is unchanged. My period is 360. While the last 2 problems, we changed the period. This problem, the period is unchanged. And so I'm still going to be putting a point every 90 degrees. But where that first point goes, that's what's going to change. Because my first point normally would be up here at the top on the axis. But the minus 90 changes that. The minus 90 tells me that point actually has to be over to the right by 90. So I'm going to put my first point right there. Now, a little hint here, something that I'll see sometimes people do that can help with this is they will actually even put a dashed line over here to show where our new starting point moved to. If you want to do that, that's fine. It's another way to keep track of where every single point goes. And you just want to be able to keep track of all these different little moving pieces. All right, now if that's the top, the next point goes at the middle. Then we go to the bottom. Then we go to the middle. How do I know that? Because I know the pattern for cosine is top, middle, bottom, top, middle, bottom, middle, top, so on. And I can follow that same pattern going from right to left. And so top leads us into middle there. Draw the curve in through those points, and you have your answer. All right, so for doing this one, we're graphing y equals cosine of 3 theta. Now, this is the first one we've done where we have a 3 in there. First thing I always want you to do whenever we change the period is to calculate what your new period is. And so that means doing 360 divided by whatever we're multiplying in there. That's 3. 360 divided by 3 is 120. So that means that between 0 and 120 degrees, I have to complete one full cycle. And then if I go over another 120 degrees past that, I'm going to complete another cycle, and then another 120 degrees past that, I'm going to complete another cycle. And as you can see there, that breaks my entire graphing grid from 0 to 360 into 3 pieces, hence the 3 up here. I'm going to complete 3 full cycles where I used to just complete 1. Now, if I'm going to be doing that, I need to know how often to put a point. And so I'm going to take my 120, and I'm going to divide it by 4. 120 divided by 4 is 30, which means that I'm going to put points at 30-degree increments, which conveniently enough on our graphing grid, you'll notice, is every hash mark. Because if this is 90 and I divide 90 by 3, each of those must be 30. So I can now go ahead and start plotting my points. Now for this one, I'm going to go ahead and sketch in the top, the middle, and the bottom lines just to help us remember that that is a useful tool. So I start with my middle, and then I drew the bottom, and now the top. All right, we're now plotting our points. First point for cosine starts where? The top, the middle, or the bottom? Yeah, it starts at the top there. So we put our first point at the top. And then I know my pattern. I go from top to middle. It's just remember where the middle is now. The middle is over at 30 degrees. And I know that, remember, because of this. I did the 120, my period, divided into 4 pieces. And so top, middle, next up is bottom, middle, top. There is one full cycle of my cosine graph. I now just need to keep repeating the same pattern that I went through on that in order to fill up the rest of the graph. So I'm just going to keep following the exact same pattern every 30 degrees. And so check your points, you got them all in the right spots, and then draw your curve that goes through each of those points once you made sure they're all right. Up to this point, we have now seen every possible transformation that we can make with these. Now we're still getting used to them, we're still getting comfortable with them. But sometimes the best way to deal with the way that all of these things are taking place is to go ahead and put them all into one big bucket and then figure out what's doing what. So for our last one, we are now going to make a graph with just about every possible transformation we're going to use. So write this equation above your next graphing grid. And then go ahead and start making the graph. And the big hint here, of course, is start by drawing in your midline. Then draw in your top and bottom. It's going to help immensely. And you hopefully are noticing that a lot of these numbers are the same one that we did just a couple graphs ago, right? So we can already know the midline's at 1 and the amplitude is 2. And so that's where we're going to put our midline and our top and bottom lines. And so check that you first plotted those midline, top, and bottom lines all in the right spots at the start there. All right, so also from that previous problem that we did, we saw that the minus 90 moves the entire graph right 90. Now, I'm going to go ahead and draw in the dotted line like I had mentioned you can do earlier, just to help visualize what we're doing here. But I now also still need to deal with the period. So remember, for period, I end up having to do 360 divided by my frequency. So I'm going to divide it by 3, just like we did before, which is 120 degrees. So my new frequency is 120. And just like we saw before, 120 divided by 4 is 30. So I'm going to be putting a point every 30 degrees, which of course is still every hash mark that we see on this particular graphing grid. So now it's time to put all that stuff into action. You want to find out where your first point goes. It's cosine. Does your first point go at the top, the middle, or the bottom? Cosine, it starts at the top. So put your first point at the top. I can easily tell where the top is because I can see the dotted line there. If you don't draw in those dotted lines, it's hard to locate that point off in space because it's going to seem like it's just totally random. Then, my next point goes middle. Now remember how far over you go to get to the middle. The middle is going to be over 30 degrees. If you got that, then I'm betting the rest of it went pretty smoothly, because then we're just following the pattern, putting a point at every single one of those hash marks as we go. And of course, when we head to the left, you're still just continuing the same pattern. And so like if this point's at the top here, I know as I head to the left, it will then go back to middle, bottom, and middle. I know all of those points because I know the pattern of cosine. If it starts at the top, then it goes top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, top, and over and over and over again until I fill up my graphing grid. Once you draw the points, draw the curve that goes through them.